SLI update. Let me have a sip of water.
All right, so let's get into this. Tell me about the SLI update. There's
a lot going on
through
here.
my sheet of paper here.
A lot going on. A lot of questions.
Yep.
A lot of questions. So first of all, let me show you this. There is a new bridge.
No LED on it.
There is no LED. There's a nice green strip on it. Yeah, you're right. There's no LED on the bridge. It's called the SLI HB bridge.
Okay? High bandwidth.
High bandwidth bridge.
Right.
It's actually double the bandwidth of the prior bridge, and even more than that because we're running at a higher frequency.
Yep.
So the first thing with Pascal is our interface on Pascal obviously is faster than it was on Maxwell. So when we have properly tuned bridges, like the high-speed bridges, we can run that interface at 650 megahertz. Prior bridges that were the old SLI kind of floppy cables and even rigid cables before LED days, those were not as well designed for high frequency because all of our GPUs were slower. So with Pascal, we're now able to run those at 650 megahertz as well. So it's not just the new high bandwidth bridge that runs at 650.
You're able to run the LED ones at 650.
Yeah.
The ones that before that do not.
400, right? Because electrically they're just not as fast as the other ones, okay?
Right.
Now we can detect those bridges and we'll automatically configure it correctly.
Yep.
Okay, so there's a new bridge. Now what can you do with the bridge? Well, the bridge actually connects two GPUs together, so both of those MIOs, we call the interface MIOs, those are directly connected for two GPUs.
So both SLI connectors on a GTX 1080 connect to both SLI connectors on another GTX 1080 to do SLI, whereas before, you're only connecting one of those.
Exactly. Before, there were two because you could do more than two GPUs and you would connect these up in interesting topologies.
Right.
Now they are both connected directly to each other and we're doing two GPUs.
Okay.
I'll cover that in just a second. Okay, so what you can do with this new bridge is all about higher configurations of displays. Over the years, what's happened is the bandwidth required to talk to multiple displays has gotten higher and higher and higher. You know, more pixels, higher refresh rates means you need more bandwidth to cover that screen.
Right.
So what's happened is our standard bridge is sort of run out of bandwidth at a single display running at 25 by 14 and 60 hertz. This is roughly the limit that we can support on our older bridges with Maxwell. Okay. Now, with our high bandwidth bridge, we can actually support 25 by 14 at 120 hertz up. We can support 4K, we can support 5K, and we can support surround. Now, when I say support, it's important to know what am I talking about.
Yeah.
So all of these configurations work, obviously, on Maxwell. But what we're able to do with Pascal is run those natively over the bridge. Before, we didn't have enough bandwidth on the bridge, so some of these transactions would run through PCI Express. And as some people know, there's a lot of contention on PCI Express, and it's a little less assured interface. With our bridge, we're actually doing what's called a display interconnect.
Right.
So this is as if literally we're scanning out of a remote frame buffer and putting it on the pixels going to the screen. Okay, it's exactly
it sounds a little bit like the actual scanline interleave.
It sounds like
it's almost like
it's as if we're really doing scanning from the other GPU, right? So that's why there's a bridge, and the reason the bridge got higher bandwidth is because of new monitor topologies, including surround. So 25 by 14.
So if you had SLI 980 Ti's and you had a standard bridge, you could run 4K. But it was transferring over the PCI Express bus.
Exactly.
It is transferring over the PCI Express bus.
And the reason it's doing that is because
there's not enough
bandwidth
on the bridge.
Yeah. And that's not horrible. It's just we can do better by having a hardware bridge. We can deliver better experiences, and we're all about that, right? So we're making things better and better and better as we go forward. Okay. So that's why we have a high bandwidth bridge. And that's
I guess I see the little note down here. It says it supports all resolutions, but it's smoother gaming with the higher.
Absolutely. Okay, so this is the one I've had a lot of questions on. Our multi-GPU support is changing with Pascal. And the reason it's changing is primarily because the way games are being developed and the way games are supporting multi-GPU is changing.
Right.
So at this point, it's time for NVIDIA to start leading a little bit on this topic. So the first step is education. This is
education.
This is education, I'm sorry. Okay, so the way to think about it is there are in fact now 3 modes that Windows is exposing for multi-GPU on DX12. Okay, the first one is called multi-display adapter mode. And the way to think about multi-display adapter is it can be any vendor, it can be any color, it can be any shape GPU, it's just an adapter. And each adapter is completely logically separated from every other adapter. right? Not the same vendor, not the same frame buffer, not the same number of shaders. They're separate. Okay, and the way to think about that is the application is now responsible for any kind of multi-GPU architecture.
How they want to break up their workload, how they want to recompile all that data afterwards,
Absolutely.
time it, all that type of stuff.
The entire algorithm for multi-GPU scaling is in the application. Okay, the driver doesn't do anything. As a matter of fact, from a driver's perspective, you can break it down into pieces. There's something called an adapter, which is a Microsoft term that says, tell the app how many adapters there are. So in MDA mode, however many GPUs there are, that's how many the app sees. And the app sees independent adapters, and it can do whatever it wants.
So if you have multiple NVIDIA GPUs in your system, it'll say, we have 3 adapters.
It'll say adapter 1 is this, adapter 2 is this, adapter 3 is this, and the driver has done nothing, right?
Okay.
Now, there's another level of abstraction beneath adapter called a node. And sadly, it's needed to understand this, right? So with multi-display adapter, there's one node per GPU. Okay, nodes per adapter, there's one. And effectively, again, the MDA mode means it's just one GPU.
So there's one node per adapter, but you could have
multiple adapters.
Multiple adapters based on the number. Okay.
Yeah. Okay, and you can have any number of GPUs supported, and you can't use scans. So this is the column that some developers are going to use going forward.
I believe that is how Ashes of the Singularity wrote its multi-GPU.
I believe it is, and that's why you can do heterogeneous GPUs, right?
Yep.
Any game that's allowing you to do different vendors has implemented some algorithm here. Right, and that's multi-display adapter mode, and it's an algorithm that NVIDIA did not develop.
Okay.
Right. So we don't support any number of GPUs. We don't support anything. Right. We support.
So
we do support the mode.
If the game said you can use 4 GTX 1080s,
go for it.
Then boom, install 4 GTX
Absolutely.
1080s. To it. I gotcha.
And that's why this is a little complicated. You need to understand that this mode is fully supported for n number of GPUs that you want. Right. Now there's another mode called linked display adapter mode. Now, linked display adapter mode, unfortunately, has 2 sub-modes. Okay.
So LDA is linked display adapters.
Yes, linked, and it's called linked display adapter because the 2 display adapters are, in some sense, connected together from the application's perspective. Now, the way to think about it first is those displays, the adapters that are linked together, are presented as one GPU to the app.
I see.
Okay.
Okay, right here. So that no matter what you had, if you have 2 1080s, they show up as one adapter. They report back as one adapter to Microsoft.
And so the GPU, this is to the app, right? So the driver is responsible for doing anything underneath that hierarchy of abstraction. Okay. In this mode, there's one node and one adapter, and the NVIDIA driver does everything. We call that SLI. Right?
And this was DX11.
This was DX11 and
DX10, 9. But I mean, all SLI and DX11 was the center column.
Yes. Okay. And it is it uses the bridge. Now what's changing, and I want to be straightforward about it, is right now NVIDIA is saying 2 GPUs are going to be our focus going forward for Pascal in this mode. Okay, and the reason we're saying 2 is strictly because games are changing, right? Games are doing multiple frame dependencies. So they're doing things like using the results of one rendered frame and the next rendered frame. And the whole process of getting SLI scaling is all about helping developers untangle that. And what we're finding is that it's becoming increasingly difficult to do that beyond 2. Okay, so our strategy is we're going to continue working on getting 3- and 4-way games, and I suspect, and I am fairly certain we're going to have success, but it is completely up to the developer to make that enabled, right?
What does the developer have to do to enable this?
They have to avoid interframe dependencies.
Okay.
Right, so if you have one frame that is directly connected to the next frame, like you're doing let's say you're doing a shadow map that you're going to use in the next frame, if you code that explicitly to be dependent, then there's no way to extract any parallelism.
None of this table is Pascal specific.
Right.
This applies to Maxwell.
Oh no, this is Pascal specific.
Well, the modes, the MDA,
the modes
LDA.
are not Pascal specific. The 2 is Pascal.
Right. Well, I guess my comment at this point would have been like we tested 3 DX12 titles. Rise of the Tomb Raider and DX12, Hitman and DX12, and Gears of War, the UWP version, which is obviously DX12. None of those 3 games scaled with the GTX 980 in SLI, right? And that is an indication that their game engine just has interframe dependencies, and so it did not scale in SLI?
I don't want to talk specifically about those 3 titles because obviously per title is going to be a different reason.
Okay.
And the truth is that we're going to continue to work with all game developers, just like we do today, to continue to do titles that are very good for SLI and for multi-GPU scaling in general.
Yeah.
Depending on the mode they select, we'll work with them, right? But this is an application decision.
Right.
Okay?
Okay.
So the key thing again is going forward, we're encouraging people, hey, NVIDIA thinks that 2 is the right number if you're going after this mode.
Okay.
Okay, and as a matter of fact, we're gonna make it so that end users can still configure for 3 or 4 if they really want to, if you're doing benchmarking, if you're enthusiast, but most people should stick with 2.
So it's important to note that.
Yes.
Questions are all over on
Yes.
the here and here.
Yep.
2 is recommended. 2 is supported.
2 is recommended and supported.
Right. 3 and 4 will be enableable.
Enableable, but
Enableable.
I recommend that if you, and the reason it's not just on out of the box is because what we're trying to communicate to the market is if you think it's just going to be, beautiful all the time, you're mistaken, right? And I want to make sure people don't just buy 3 and 4-way by accident. You should really know what you're doing when you buy 3 and 4-way.
Okay. I mean, to a certain degree, I can appreciate that. You're basically saying that you don't think the ecosystem going forward for 3 and 4-way SLI is going to be a very positive experience or a good, efficient use of your money.
I want gamers to be absolutely delighted with their experience, right? I want anybody that's going to buy multiple GPUs from NVIDIA to go, oh my God, this is the best thing I've ever done in my lifetime.
Right.
And given the fact that we know what's happening with the way drivers are changing and the way the architecture is changing, right now it's hard for us to say 3 and 4 and 5 and 6 is going to be fantastic, right?
Right.
And until we can really say that with a straight face, we have to say, hey, let's focus on 2. Everybody who buys Pascal can get an amazing experience with 2.
I know we haven't talked about this third column yet still, but I'm just asking, do you envision a future where we are ramping that back up, where software has changed in a capacity where we're able to utilize more than 2 GPUs with less effort?
I mean, we don't know what's going to happen, but in a different world, we already know that scaling beyond 2 GPUs or beyond 2 cores, like if you think about a CUDA core, that is already doing scaling.
Right.
But it's using a different architecture, it's a different paradigm, it's a different software model, and at some point, all of this could change. And whenever that did change, of course, we would be at the front of it, right? So I do think that MDA could become very common. There's lots of innovation happening with multi-display adapter mode, and it's totally reasonable to expect games to get better and better and better at it. That's kind of why this was done.
Right.
Right. The reason this is done is to say, the way to solve this in a real way is to make it application aware.
Right.
And hiding it underneath here means that we have to go retrofit into games a lot.
Yep.
And so what we want to do is make the games, kind of aware of it.
Figure out
a better way.
All right. Explain this third column to me.
Okay, the third column is really similar to the first column. It just allows the game developer, because the big thing about the third column is it's also application.
Okay.
Okay, and in this mode, it allows the application to leverage some of the resources that are available if the GPUs match.
Okay.
Okay, so if the GPUs are matched, then you could do LDA explicit mode, and you could get some benefits over just doing MDA mode.
Okay.
Yeah. So this is actually what we are recommending game developers do if you're going to do an explicit SLI kind of architecture.
Okay.
Yeah.
Right.
Okay, so that's SLI.
If you enjoyed this content, consider supporting in-depth technical content by contributing at patreon.com/PCPer.